Good afternoon, everybody. It's a great pleasure to be back here with you again. Today's talk is going to be one I think that will interest most of you because it addresses the very important issue of the woman's biological clock. And you're going to learn that the biological clock refers to the way in which the woman's age and her proximity to the menopause impact on the quality of her eggs and therefore the quality of the embryo she'll produce and outcome with IVF. Before I do that, let me just again remind any of you that are interested in connecting with me by through a consultation by Skype that you can call by dialing 702-533-2691. Again, 702-533-2691, and speak to Julie DeHaan. Julie is my concierge, and she'll be glad to set you up with a consultation via Skype with me. Of course, if you live in Nevada or in the area or want to attend an in-person consultation, she can arrange that as well. Julie can also be reached by going to my website, which is shareivf.com, and then finding the little enrollment form. All you do is fill in the details, shoot that off to Julie by email, and Julie will basically then get back to you for a consultation. Alternatively, you can email Julie directly at julied, Julied, at shareivf, SHERIVF.com. julied at shareivf.com. Okay, and one last thing. My website is shareivf.com. And to get to my blog, in order to read all the articles that I've posted there, or to read selectively, by simply posting any title into the search bar you'll find at the home page, you go simply to shareivf.com. Okay, let's talk about the biological clock. Now, you should know that there are two factors that determine the quantity and quality of a woman's eggs. First, quality. That is the chromosomal integrity of the woman's eggs. Remembering that it's the egg and not the sperm that is the most important determinant of whether the fertilized egg or embryo will be normal and capable of propagating a healthy baby. Normal means that the embryo should have its full complement of 46 chromosomes, resulting from the fertilization of an egg that will have 23 chromosomes and a matured sperm that will likewise have 23 chromosomes, bringing us to the 46 in the embryo. An embryo that has more than 46 or less than 46 chromosomes is incompetent. It is aneuploid, and it is derived almost always, in more than 75% of cases, from the egg having been aneuploid. In other words, the egg having had less than or more than 23 chromosomes when it was fertilized. Not so much the sperm. Although in cases of significant male infertility, where there's reduced male morphology, that's appearance, and motility, that's movement, and count of the sperm, if it's significant, then that can further increase the risk of embryo aneuploidy. Now, so how does a woman's age affect the likelihood of the egg being normal? Firstly, let me say that humans are the poorest of all mammals when it comes to the competency of the female's eggs. In fact, only 1 out of 2 eggs at best in young women in their early 30s or late 20s will be chromosomally normal when it is ovulated or extracted. That means it'll have exactly 23 chromosomes. All the rest will be abnormal. And as the woman gets older, to the age of 34, 35, only 1 in 3 will be normal. When she gets to 40, maybe 1 in 6 or 8 will be normal. And when she gets to 42, maybe 1 in 10 will be normal, with 9 in 10 being aneuploid or chromosomally irregular. And when she gets to 45, alas, only 1 in about 20 to 25 will be normal. Now this, from what I've told you, should get you to understand better why it is that as women get older, the chances of an egg fertilizing is reduced. In other words, infertility is more prevalent. The chance of a fertilized egg attaching is much less likely. The likelihood of it staying attached rather than miscarrying is also less likely. And that if the embryo does attach and go on, it will be more likely to have a chromosomal defect, resulting in an abnormality such as Down syndrome. And that is why infertility, miscarriage, and birth defects that are chromosomally linked become progressively more prevalent as a woman gets older. It's another reason why as women get into their mid-30s, and if they're not contemplating having a baby within the next few weeks, a few months or years, they certainly should be considering banking their eggs and storing them for future dispensation. So that's an issue where age affects egg quality. And how does it do it? Primarily through a wear and tear effect on eggs that have been in the woman's ovaries ever since she was inside her mother's uterus. And over time, these eggs start to degrade and do not withstand the hormonal changes that they go through to get them ready for maturation. And maturation occurs in the normal, natural state through the onset of the so-called LH surge that you measure in the urine with a special dipstick that you can buy over the counter. When the LH surge occurs, it sends the eggs into what we call meiosis, or reproductive division, which halves the chromosomes from 46 down to 23 in the ensuing 36 hours to 42 hours. And so the egg ends up, as it's ovulated or extracted, as having 23 chromosomes. If it ends up with more or less than 23, as I stated earlier, it is incompetent. And age is by far the most important factor that will determine whether the egg will be competent or not. It's not the only factor. As I said, if there's severe male infertility, it can, upon fertilization of the egg, result in the fertilized egg or embryo having more or less than 46 chromosomes and thus being incompetent. But there's another factor that's more pressing in the context of IVF, and I've repeatedly stated this in previous conversations, and that is the environment created by the fertility drugs we use to stimulate the woman. It's no different than growing a plum tree in your backyard where there's an inadequate environment because you're growing at the dark end of the garden and there's poor irrigation to the soil. The plum tree may develop fruit that even upon being ripened will look juicy and red and delicious until you bite into it. And then you won't want to eat it because it tastes badly. Why? Because the final maturational process, which is the end point of fine-tuning development, went awry because the preceding development was inadequate. The egg is your plums, and the plum tree the ovaries. You have to establish the optimal environment, and that differs from woman to woman. So for older women who are more vulnerable to the eggs going abnormal, or women who've got, as we're going to discuss in a minute, on top of it, diminished ovarian reserve, you need to be more careful and selectively identify and choose the best possible protocol that will protect the eggs during development, so that during stimulation you will end up with an egg that is perfectly mature with 23 chromosomes only, and then the chances are optimal. That doesn't mean that that egg, if you do those things, will be normal, because that's when age steps in and you deal with the statistics that I told you earlier, namely that at the age of 40, 1 in 6 will be normal, and at 30, 1 in 2 will be normal. The best you can do is to optimize the chance of an egg being normal. Another good analogy is to say that when we stimulate women, we are basically playing the hand that nature deals us, the eggs that are available to be subject to stimulation. We don't shuffle the deck, we don't deal the hand, we play the hand we dealt. And if you play the hand poorly, whether the eggs had the potential to make healthy, normal eggs and embryos upon fertilization or not, you'll get poor embryos in the end. But if you play the hand as if it's a winning hand, optimally, then those eggs that had the potential to yield eggs that would make embryos that are normal will exercise that potential, and you'll have the best chance of success. That's what IVF's about. I tell people over and over, nothing is more important than the way in which you individualize and strategize the protocol used for ovarian stimulation. Now, the second issue is the issue of how many eggs you can produce. In other words, how close are you to the menopause? A woman's born with all the eggs she's ever going to have. And as she gets older, she uses up more and more until the number dwindles. When the eggs population in the ovaries drops below a certain theoretical threshold that might differ from woman to woman, at this point, the pituitary gland starts to try to get more out of the ovaries in terms of more eggs, but of course it can't, because once the eggs are used up, you can't make new eggs. And so it cracks the whip louder, much like a mule driver would crack the whip louder to get more out of the mule pulling the cart. But in this case, when you reach the point of maximal potential, that mule just can't do the job any longer. The same with stimulation. If you stimulate a woman who's got diminishing ovarian reserve, when you reach the point of the maximum potential to produce follicles which contain the eggs, no matter how high you push the stimulation protocol, you will not improve that potential. And so it's important to identify how many eggs are likely to be left in the ovary, so you can best identify the best protocol as well as the right dosage of fertility drugs necessary to optimize response. You do that by measuring hormones on the second, third, and fourth day, second, third, or fourth day of your period. Day one is the very first sign of any bleeding whatsoever, even if it's minor. And the hormones you measure are primarily FSH, LH, and estradiol. The FSH level goes up as the ovarian reserve declines, as a woman starts running out of eggs. When it goes over 9 million international units per milliliter, if that occurs in association with a normal blood estradiol level of under 70, then it suggests that the ovaries are running out, starting to run out of eggs, and that ovarian reserve is diminishing. We call that DOR, diminished ovarian reserve. But a far more important test than the FSH, LH, and estradiol is to measure the AMH, anti-Mullerian hormone. If this level drops below 1.5 nanograms per milliliter, it's in the range of being significantly depleted. If it drops below the normal of 2 down to 1.5, you're in the gray zone. But once it drops below 1.5, you're getting into a range of trouble when it may be indicating that you're running out of eggs and it's being depleted. This can then follow very rapidly, where it can drop down to the 0.1, 0.2, 0.3 level, or even lower. Very quickly. It can happen in months, or it can take years, and there's no way of determining how long it's going to take. So it's important to get those measurements, and then to decide how aggressive and proactive you want to be based upon the knowledge of how many eggs are still left in your ovaries. And here's another little pearl, and it's this. A woman who has diminishing ovarian reserve, in that woman, stimulation is the selection of the protocol is even more critical. Because if the ovarian reserve based on AMH and FSH is declining, then you need to be much more individualized. So age is one factor that affects the ultimate egg quality, but the ovarian reserves helps you modify and modulate the protocol to optimize response and protect the eggs. You will have a much poorer chance of success if you use a recipe approach, a one-size-fits-all in a woman with diminishing ovarian reserve. I would say that my practice is probably 75 to 80% women who have egg-related problems, either because of diminishing reserve in the ovary and or advancing age. And that's why I see so many women who give a history of poor quality embryos, much, not all, but much of which can be prevented by using the appropriate protocol based upon the parameters I've given you. Now, age and ovarian reserve together, collectively therefore, are referred to as the woman's biological clock. And as that changes, so the clock gets depleted, or it is running smoothly. Now, what do we do with women who have a very high ovarian reserve based on the biological clock testing? In other words, the AMH is very high. Such women are at risk of overstimulation, ovarian hyperstimulation, which is a life-endangering situation. And in these women, you have to back off on the dose, lower the dose of stimulation, and do it in readiness for something I've referred to earlier on as prolonged coasting. It's my preferred way of dealing with this problem, rather than using other approaches you sometimes hear of, which is using a lower dose of HCG, which is an analog of LH to trigger the maturing of the eggs, or using the so-called Lupron trigger, when you give too little of a trigger, or when you use the Lupron trigger, you may reduce the risk to the woman, but you do it at the cost of egg quality and therefore embryo quality. Whereas with prolonged coasting, which I won't go into here, and I urge you to go to my blog, shareivf.com, and then type in prolonged coasting into the search bar of the blog and go read up on how we do this, because this is a way of avoiding damaging the eggs as severely and still at the same time not having to cancel a cycle because of the risk of severe ovarian hyperstimulation. And then there's the other end of the spectrum, where the woman has depleted or very low ovarian reserve but does not want to use an egg donor. And in those cases, there's only one other option, in my opinion, and that is to do what we call embryo banking. Here we stimulate the woman using an individualized approach. We harvest her eggs, we fertilize the eggs and take the eggs to full development, and then biopsy the blastocyst to do PGS testing, something which I was the first to introduce in the field back in 2004 in the clinical realm. So you take one cell or more from the blastocyst, usually 4 or 5 or 6 cells, you pool the DNA and you do DNA testing of that blastocyst to see whether it's chromosomally normal. Now, some chromosomally abnormal blastocysts can recover in the course of after having been transferred to a woman's uterus. This usually happens because of a condition called mosaicism that I've already alluded to in a previous live feed, and you'll also find information on my blog. Mosaicism occurs when some of the cells are normal and some are abnormal, and it can autocorrect. But if the abnormality of the blastocyst results from the egg having been abnormally developed because of something occurring during meiosis or maturational division, that is permanent. It's not always possible to tell whether an embryo is abnormal because of mosaicism or meiotic aneuploidy. But we can take the chance to put some abnormal embryos back, even if they're abnormal, and usually I like to confine that to cases where there's only a single abnormality of the non-sex chromosomes, usually a deficiency of one chromosome. We call that monosomy, because those embryos, even if they were to take, won't hold, and there's not the risk of a woman really having a developmentally abnormal baby. Whereas if there's more than the 2 chromosomes, we call that trisomy or more, then there is a risk of an abnormality. So I'm much more careful in recommending putting embryos that are abnormal back with a single chromosome abnormality when it's the addition of a chromosome, because that's when you run into trouble. And if an embryo's got numerous chromosomal defects or is complex aneuploid, it's got numerous defects, such embryos haven't got a hope in hell anyway, and you don't want to use them. You want to discard them, in my opinion. Now, in those cases, therefore, where we get these embryos and we biopsy them, we can then stockpile the blastocysts over several cycles and bank them until there are several of them. In many cases, we can avoid having to do the genetic testing over and over and incurring compounded expense for the woman or the couple. And we can do that by holding on to the biopsied cells and DNA until we've got enough blastocysts, until the woman says that's enough, or from our perspective, we recommend stopping because there's more than 6. And under those circumstances, we would then do a single test on all the blastocysts we've heaped up and get a result. And then by knowing which embryo produced which biopsy, we're able to then cross-reference and know which embryos are normal or abnormal, and subsequently come back with frozen embryo transfers and put back those embryos that have been so selected based upon normalcy or suspected mosaicism, and put back no more than 1 or 2 at a time until a pregnancy occurs. The embryo banking process isn't perfect because chromosomal abnormalities of the embryo are not the only age-related reasons for the embryo being incompetent, but it's certainly the most important reason. And we can significantly improve the chance of success by using embryos so selected, but always bear in mind doing the testing does not make better quality embryos. It simply identifies the ones that have the best potential. And so from that perspective, it is helpful to improve pregnancy rates or baby rates per embryo transferred. It also reduces the miscarriage rate because most miscarriages are also due to chromosomal aberrations of the embryo. And if the embryos are normal, you can reduce the miscarriage rate from as high as 40% in women in their 40s down to 5 to 10% if you do selective transfers of embryos. It also markedly reduces the risk of birth defects. So, in summary, an appreciation and understanding of the biological clock is central to optimal IVF treatment. Any woman undergoing IVF deserves to have the protocols used for stimulation based upon a proper and thorough assessment of her biological clock. And this is especially important in older women or a woman of any age who has diminished ovarian reserve, who tends to be much more vulnerable to the changes that take place in egg development and can corrupt egg and embryo development. So I hope that's helpful to you. And again, if any of you want to discuss your case with me, simply go to shareivf.com, fill in the questionnaire there, send it off to Julie, or call 702-533-2691. And thank you so much for your attention.